In this video, we're going to begin looking at a special type of inequality called a tripartite inequality. As its name suggests, a tripartite inequality is a three-part inequality. We use a tripartite inequality when our variable is between two numbers. For example, if I were to write 2 is less than x is less than 7, our variable x then is between 2 and 7. Often we will have to solve these tripartite inequalities, and when solving, we will balance not just the left and right side, but we will balance all three parts, left, right, and center, of the inequality. And when graphing, we will graph the inequality between the numbers. Let's take a look at an example where we can see this work out. In this first problem, we have the 5x plus 7 between the numbers 2 and 22. To begin isolating the variable, we will subtract 7 from all three parts, left, right, and center, on the inequality. This gives us negative 5 is less than or equal to 5x, which is less than 15. To isolate the x, we divide both sides, or all three sides, left, right, and center, by 5. We now have negative 1 is less than or equal to x, which is less than 3. With the x alone, in the middle, we have solved the inequality. We can graph a picture of the solutions on a number line. At negative 1, because the graph is or equal to, we will need a closed circle. At 3, because it's strictly less than, we will use an open dot. Because x is between these values, we will graph between those values on the number line. We can also represent that graph using interval notation. The small number is negative 1, comma, the big number is 3. Because we have a closed dot, or the or equal to, we have a square bracket on negative 1. 3 is an open dot, or just strictly less than. It gets a curved bracket. Let's try one more example where we can see solving the inequality on all three parts. In this inequality, we see the 5 minus 4x is between 5 and 13. We begin balancing by subtracting the 5 from all three parts of the inequality. As we do, on the left side, 5 minus 5 is 0. This does not mean the left side of the inequality disappears. We just write 0 is less than negative 4x, which is less than or equal to 8. To isolate the x, we divide all three parts by negative 4. Notice on this step, we're dividing by a negative. This means the inequality symbols will have to flip over and change direction. We get 0 is greater than x, which is greater than or equal to negative 2. To make this inequality more familiar, we might flip the whole thing over, so the inequality symbols open to the left. Negative 2 is less than or equal to x, which is less than 0. This will make it easier to graph. At negative 2, we see we will need a closed dot to represent the or equal to. At 0, an open dot. Connecting them will finish the graph. In interval notation, we're going from negative 2 to 0. Square bracket at negative 2, and a curved bracket at 0, reflecting the graph. Any number between negative 2 and 0 will make the tripartite inequality a true statement.